Okay, so welcome back again, and this is Chipmaster, and in this video series I'll be doing a repair on a Acer, a bit old school, yeah, and I got it from another technician and he said that the laptop is not turning on, right? So I'm gonna connect the power supply and check the current consumption on this thing. Alright, so I'm plugging in the charger now and see, pressing the switch, not getting any lights at the front here. Normally we'll get a charging indication at the front here, but I'm not getting any orange light. This is the charging light and this is the power LED. I'm not getting any lights, so I'm pressing the switch now. Nothing. Alright, so I'm gonna take this unit apart now. Okay. Let's move out a bit. Just for demonstration purpose, just in the mood for taking apart the laptop on camera. But normally I don't do this because it's a waste of time. But I just feel like I'm in the mood now to take apart this computer. Oh, I nearly bent the CPU pins right there, shouldn't even be there. Alright, so removing these screws. I'm trying to get the thermal camera to work on this computer system, but it's not working. I'll have to use the other computer. Okay, screw here. And the speaker wires, speaker connector. Oh, the hard drive is already. Oh, it's using an M.2. Okay, so it has both connections for M.2 and a regular SATA hard drive. Alright, so as I pulled it, I'm now just visually inspecting for any burn or any liquid spill or any corrosion or anything that is not looking right, and it seems all good. And this is a dedicated graphic card here, most likely an NVIDIA graphic card. Alright, so everything looks good on this side. So I'll have to take out the board to check the next side. Alright, taking out the RAM, sorry, the Wi-Fi. Alright, so I'll just move this out the way. And I don't see any burn or any liquid damage. Board is completely clean. Let's take a look closer. Alright, so as you can see, there is no burn, just a little dust right here on this side. Okay, so I will get the multimeter and I will now check all coils for shorting. So first of all, I will start with 3 volt and 5 volt section here. Oops, I'm not on diode. Alright, let's pop this in a little more. Okay. So the diode mode value reading, let's go. Alright, 3 volt and 5 volt is right here. Alright, so on this coil I get 79. I hope that's the RAM. Let's check if that's the RAM. Yes, it's the RAM. See it increase each when I remove the RAM, the resistance increase. Put it back in. It's right there at 70. It's 80. Alright, so this is 3 and 5. Alright, 900. Oh, I didn't realize that I have the red probe on ground, the black probe on ground, and the red probe should be the reversed. I get 107. I was getting the wrong reading because the polarity was forward. It needs to be reversed. I get 151 when the RAM is out. Put it back in. I get 102. 106. Alright, so 3 volt. Alright, 5 volt. Alright, excellent. Let's check the graphics card. Let's check the CPU core first. I'm getting 6, that's good. Graphics, VCC GT, that's good. Alright, this is the bus VCC 1.0. VCC PRM 1.0, that's excellent. Alright, so let's check VCC SA. That's also good. Alright, graphics core, that's also good. Alright, this is for the video memory, 1.35 voltage, and that's also good. 102. This one is, they are connected? No, they're not connected. This is the graphics card. Oh, one is for the charging. This is the charger battery, 497, that's good. This is the graphics card core, and this is most likely the bus power supply for the graphics card, 103. Okay, alright, so let's check the 19 volt rail now, and it's also good. Alright, so everything is all the resistance are okay so far. So I'm gonna connect the charge port. Let me get the charge. The DC jack. Alright, so plug it in the charger now. What the hell? This thing is taped up. Why is this taped up like this? What is this? Oh, so they did a repair on the port. Let's check if this port is actually working. let me check if it's working. If there's any 19 volts coming through, should get in 19 volts. Alright, this is ground, the main. Yes, so the port is working. Alright. Yeah, sorry about that. Alright, so let me connect this thing to the board. I have a strong feeling that this thing will just work, because I haven't get any abnormal reading on any of the coils or anywhere that is sensing a short circuit. Alright, so plugged in the charger. Alright, let me back out a little bit. Alright, so I'm gonna check some voltages now. So I'm gonna check the 19 volts first to see if 19 volts is coming through the current sensing resistor, and I'm getting 3.7. So this is abnormal and it's jumping, as you can see. It's not supposed to be jumping like this. So could it be that this MOSFET is broken? So could it be that this MOSFET is broken? Alright, so let's check. First, we have the source. This is coming from, the drain. It says the voltage is flowing from drain to source. So the voltage is flowing from drain to source. I think I'll go under the microscope for this one. Okay, so now under the microscope, I had to get a third camera, a fourth camera rather, for the microscope, for the multimeter. Alright, so here is the MOSFET, as you can see. So first of all, I'm going to check, as I said before, the voltages flows from drain to the source instead of from source to drain, right? And as you can all know, let's turn the multimeter to diode mode. So I'm going to first check red probe on drain, black probe on source, and I don't get any reading, as you can see, right? Now let me flip it around, and I get 522. So this is a N-channel MOSFET. As you can see, my red probe here is on the source and my black probe here is on the drain. So I'm getting 517. So this is an N-channel MOSFET, right? And MOSFET where the base or the gate should be positive, right? So it's a NPN. So the P, which stands for positive, meaning that the base of the MOSFET should be positive. So if positive voltage is going to the gate of this MOSFET, right now, based on this MOSFET and the experience on fixing, since I'm fixing these things, I know that this MOSFET should have at least 25 volts, right? So the voltage at the gate should be greater than the voltage at the source. So once the voltage at the gate is 25 volts or greater than the voltage at the source, whatever voltage is at the source here, the gate voltage should be greater than the voltage at this source. So pin 1, 2 and 3 is the source pin, pin 4 is the gate, and pin 5, because this MOSFET only has 4 pins, so 1, 2, 3 pins, 1, 2, 3, so 1, 2, 3, 4, 5, right? So it's 5 pins, 1, 2, 3, 4, 5. Normally it should be 8, but these pins are joined together for the drain, so we just call it 1, 2, 3, 4, 5, 6, 7, 8, but 1, 2, 3, 4, 5. So all these pins are connected together. Alright, so this is the drain. Alright, so I'm going to connect the power now, and I'm going to check and see what I get on the gate. Remember, the gate voltage should be high because this is a NPN channel MOSFET, or I can call it N channel MOSFET. So let's go. Alright, so the source, oops, let me check, set this to, I'm still getting 3.6. It's fluctuating, as you can see there. Alright, let's check the drain. and I get 19.9, and the voltage is stable to a point. It's jumping. Alright, there you go. So we get 20 volts there, right? Let's check the gate, and I'm getting 3 point. Alright, let me just reverse this because I have the negative probe on the power side. Yeah, 3.7 volts at the gate also. So the voltage at the gate is the same as the voltage at the source. Right? Gate voltage, source voltage, and the gate voltage the same. So we need to check the working conditions. Under what working conditions does this MOSFET need for it to work? And I said before, the gate must be greater than the voltage at its source. So in order for this to work, it is controlled by a charging IC or a charging chip. It has to be controlled by something. And who is controlling it? It is controlled by this chip. It is controlled by this chip here, which is our charging chip. Right, let me see if I can focus. It's a BQ24. Hold on. Okay, so as you can see, it's a BQ247080. Right, it's BQ24780S. Alright, let me go focus again. And this is a common charging chip that we all use. It's a BQ247. Oh, let me turn it around. Where is it? No, that's not it. So it's a BQ24780S. A very popular charging chip. A very popular charging chip here. So first of all, I'm going to check the working conditions of the BQ24780. Let me just focus this part and let's check the working condition. So I already checked the 19 volt rail and it's perfectly fine. There's no short. Normally if it's a short on the 19 volt rail, then it will shut down the drive. Let me just power here. Not needed at the moment. Right, so I'm going to check the working conditions of the charging chip BQ24780S. So let me connect the charger. Alright, so this charging chip here. Does anybody know the working conditions of this chip by hand? Dead simple. Alright, so first I'm gonna, so let me focus, make sure that I have proper focus. Alright, so the power is in. So first I'm gonna check the input pin. So pin number says 1, 2, 3, 4, 5, 6, 7. Alright, and that's 7, 14. Alright, 21. This is input. This is the last pin. That's 21, 22, 23, 24, 25, 26, 27, 28. And I get 20 volts there. Right, this is the main input. That is good. Next we need to check pin number 6, which is the adapter insertion and detection signal, which is called the AC detection signal. Alright, that voltage should not exceed 3.4 volts and it must not be below 2.4 volts. So let's check 1, 2, 3, 4, 5, 6. and I get 2.7 volts. Beautiful. So once it's between 2.4 to 3.3 volts, then it's a valid adapter insertion detection signal. Now look, if I adjust my multimeter, my DC power supply to 15 volts, it's below 2.4 volts. So this is not a valid insertion detection signal, right? So the charging chip will not produce the 25 volts for the charge pump in order for it to turn on the input, the gate of that MOSFET, because it's not a valid adapter insertion. So it sensed that the charger is not valid, so it will not send the 25 volts in order for it to produce AC or AC drive signal, which is on pin 4. So let me adjust back the DC power supply to the correct voltage of 19 volts. As you can see, the voltage should be increasing back now. Alright, there we go. So I get back 2.7. So if I decrease it back to 15 volts, that's 15 volts. Now I get 2.1. That's not a valid adapter detection. And if I put it back to 20 volts, now I get back my 2.7 volts. Alright, so please bear that in mind. Alright, so let me check back the gate of this MOSFET. Alright, so drain. Oops, I need to adjust back my DC power supply a little bit more. Oh, there we go. Alright, next we have source, still 3.7 volts, and it's still fluctuating. Pin number 4, sorry, still 3, same as the source. Alright, so the adapter insertion detection signal is okay. The main power supply for the charging chip is also okay, but we're still not getting 25 volts. Alright, let's check pin number 4. 1, 2, 3, 4. This is the output pin, and I'm only getting the same voltage. This is the voltage that is going to the gate of the MOSFET, which is fluctuating all the time. I'm checking the next side, and it's still fluctuating. Alright, so now I'm going to check if the charging chip is actually working. This is a trick that I normally use. I'm just going to run a jumper wire. I normally remove the MOSFET, so I'm going to remove the MOSFET first. So by removing the MOSFET and running a jumper wire, if I get 25 voltage at the gate, then the charging chip is okay. Most likely the MOSFET gate is leaking. So I'm gonna remove the MOSFET and then run a jumper wire and see what happens. The 25 volts is gonna be there. The aim of this repair is to get 25 volts at the gate of the MOSFET. Once 25 voltage is at the gate of the MOSFET, then we are good to go. The laptop will be fixed. Alright, so let's do this. So now my hot air is at 390 degrees. Alright, there we go. MOSFET is removed. Oops. Okay. Just adding some flux here. Alright, so I'm now going to I'm going to run the wire now. Alright, there we go. And you should, alright, so let's jump the wire. Alright, that wire is sufficient. So I'm running the wire, as you see, from source to drain. not to the gate, from source to drain. Alright, so let me just break that wire there. Alright, so let's go. So I'm plugging in the charger now. Alright. So I'm getting 20 volts here. Let's check the gate. Automatically, you know you will get 20 volts at the source. There we go. Let's check the gate. And I'm now getting 26 volts. So the charging chip is perfectly fine. So the charging chip is outputting 26 volts at the gate. And this indicates to me that the charger chip is okay. Right, so most likely I have a bad MOSFET right here. This MOSFET gate is leaking. Right, the diode here, right, there's a body diode right here, as you can see right here, and this diode is to prevent there are two diodes here. This is called a suppressor diode, or you can call it a transient suppressor diode, which takes a 19 volts. So this diode is acting as a protection. So what it does, if any voltage or any spike that is induced on this line due to EMI or electromagnetic interference, right, what will happen is that this diode has a reverse conduction value. So what happens is that the positive side of the diode is connected to the ground, while the negative side is connected to the positive. So it will become a Zener diode or a suppressor diode, and it will suppress the voltage and keeps it at a stable voltage, or you can call it a stabilizing diode in most cases, right? So any fault between these two components can cause a short circuit between the power rail here, right? Between this is the DC jack connector here. Where am I? Alright, so this is the DC jack connector, and as you can see, the 19 volts. Oops, I made a mistake there. Did I burn it? I saw some smoke. I was accidentally touching the ground right here. Oh god, that was close. Alright, let's check again. The charger was in there, I didn't realize. So the 20 volts is working fine. This is a diode, the input pin. This is the anode. Alright. And cathode, negative. And we're getting 25 volts here. So I get the 25 volts. So now I'll just look for another MOSFET. Right, I check this MOSFET and it reads perfectly fine. Let's check it outside of the circuit now and see how we get. Alright, so this is the drain and this is the source. Oops. Let's set this to Alright, and I'm getting drain to source is reading okay. And the gate is also okay. I'm going to conduct it now and it should give me 0 0 0. Perfect. So the MOSFET is working. The MOSFET is working. I will now discharge it. To discharge it, you just touch the gate and the drain and the source together with the tweezer. So I'm touching the gate and the source, and it should go back to the normal value of 495. So I'm just holding it for there for about 3 to 5 seconds. Now it should be discharged. Let me check again. Red probe on source, black probe on drain, and I get 492. Alright, let me conduct it again by touching the gate just for a second there and put back the red probe on the source, and I'm getting 0 0 0. So that indicates this MOSFET is working. So what else could be this problem? Because the MOSFET is working, but I'm going to change the MOSFET. The gate can have a leak. So let's check the source and the drain spins and see if we're getting any resistance there. And the resistance is open loop, so I'm getting infinite. No issues there. No issues there, so there's no connectivity. So the MOSFET is working. So let me try another MOSFET. And also, as I said before, there's no tension on the 19 volt rail to be causing it to not producing the 25 volts to turn on the MOSFET. because I was the resistance at the coil at the adapter current sensing resistor here. Alright, this is the adapter current sensing resistor, and I'm getting 448, and that's perfectly fine. There's no short. 452, perfect, and there's no fluctuation, so that indicates that the 19-volt bus is also good, but it wasn't producing the 19 volt here because it was fluctuating between 3.7 to 3.8 volts between the gate and the source pin. Alright, let me see if I can find a MOSFET. This is an N-channel MOSFET. Any N-channel MOSFET in a typical PWM circuit will work. Oh, turn on the fan here. Alright, so I have a donor board here. I'm going to just grab a MOSFET from. Alright. This is one right here. I'll just take this one, and this is an alpha omega NPN trans MOSFET. So I'm just going to take this one and install it on my target board. Oops, my tweezer slipped. Now I'm going to move the jumper wire, because if I leave it like this, the battery will not charge, but it will work. Oh, waiting for the iron to get hot. Just waking up the flux there. Alright, so I'm just moving the jumper wire right here. Alright, there we go. I'm just flattening back the pins, the pads, make sure they're evenly tinned. Alright, so I'm just going to install this new MOSFET now. But not really new, but you get the idea. Alpha Omega. Alright. Alright. Just removing the excess solder blobs off the board here and the drains. Cleaning it right there, it's on 99.9. Alright, let's see what we get. Alright, so I plug in the charger now. Alright, drain. Oh, sorry. Alright, so let's check drain. I get 20 volt source. Ah, so it's fixed. So it was the MOSFET that was bad. So I'll check the gate now, and I'm now getting 26 volts. Perfect. Perfect, 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 perfect. So the MOSFET was really out of order, and it didn't work. So the gate was leaking. The gate was leaking. Let's turn on back this. it was a faulty gate. Alright, so let's do another check again. Making sure that it's, so I remove the power for a couple seconds and then plugging in back the power. So let's check the gate. Drain 20 volts, source 20 volts, perfect. Gate 26 volts. Alright, so the MOSFET was definitely out of order. So let's check the standby rails now. 3.3 volts and 5 volts, making sure that all the power rails are intact before I put this unit together. Alright, so this coil should be 5 volts or 3 volts, I'm not sure. Yes, I get 3.4 volts. Right, and the next coil here is 5 and I get 5 volts. Good. Now let's check if we're getting VCC PRIM 1.0. Oh, that's not it. Let's VCC PRIM is not this coil. I'm not getting 1 volt at this coil. Is this a 6th or 7th generation CPU? I'm not sure. I'll have to pull the heatsink to see which generation of CPU is this. I think it's a 6th generation, most likely. I'm gonna pull the CPU. I'm gonna pull the heatsink, so I'm not, and then I can determine. It's, well, I'm looking at it under a small piece of it here under the microscope, and I can see that little green mark there, and I can see that that's a 7th generation CPU, which is the Kaby Lake CPU, which is the ULT version, which is the low powered Intel CPU low powered version. These are low power CPUs. Alright, let me go over to the overhead. Oh, sorry. Let me go back over to the overhead. This is light. Right there. Okay, so we get standby voltages, and the power switch is in the keyboard connector. So I'm gonna put this unit together now in the case and then see what I get now. So I'm gonna put it in and power it up. Alright, sorry about that, a call came in. Alright, so let me take this call. Okay, sorry about that, a call came in. Alright, so let me put this thing together. making sure that all its connections are in. That is in. Keyboard and trackpad. Alright, so before I just fully screw up this thing, let me just plug in the charger. Oops. Alright, so let's plug this thing in. See if we get lights at the front and form of lighting. Yep, you get the orange light. There you go. As you can see, there's an orange light right there. Alright, let me press the switch. Yes, it's powering on. Oh, it displays so quick. That was quick. Alright. Oh shoot. How the hell did these screw get out the top up here? Not seeing anything on the screen though. Oh, there we go. That's a done job. Alright, there we go. So alright, so that's it. So I think I should stop here. So in our and I hope you all enjoy the video, and I see you in another video when I will so I see you in another video when I will fix, or let me see if this was sleeping. There we go. Right, so as I said before, next I will see you another video when I will repair something for you. Okay, thanks, bye.